Hey, Sayan, are you there? Or
You muted, Sayan.
Oh, sorry. Yeah, I'm here. I'm just trying to figure out the sharing settings.
Yeah, I think everyone can share.
Um, I think I need to make some security preferences changes on my laptop. Sorry, guys. I'll be back. It's asking me to quit Zoom. I'll just reconnect.
All right, no worries.
All right. Uh, can you see my screen now?
Yeah, we can see it. I don't know if you want to go full screen or if you're happy like this.
I'm fine like this, but can you see the full screen?
It's loading, and yes, we can. Yeah, it's all good.
Cool. So yeah, the presentation is on IPDK and TDI. IPDK is Infrastructure Programmer Development Kit, which Intel at Intel we have been recently working on. We have just open sourced a big part of it. The objectives of IPDK is that we want an open community initiative ecosystem with standard APIs, programmable interfaces, support for any CPU, IPU, or networking device, like switches that can conform to these APIs and interfaces. We can preserve existing investments and existing APIs like DPDK and SBTK, and convert them and move them towards more P4 programmable ecosystems. Key use cases are infrastructure as a service, platform as a service, and inline acceleration. So this is how it has been structured. IPDK sits in the middle. You can have infrastructure applications, which could be storage, SDN, and anything sitting on top of IPDK. IPDK would have SPDK or P4SD sitting on top of device drivers. And at the very low level, you'll have you can have target specific software. This will make it more clear what I'm talking about. So an IPDK so this is an IPDK target. We have an interface, a common interface called target agnostic interface. This is mainly what we'll be talking about, TAI. Then all of these different components that you can see, SPDK, P4OVS, these communicate to with an IPDK target via this layer called TAI. IPDK complete software. If you go to GitHub and pull, the image would contain this entire thing. So that's TAI. This is what we are calling it, target agnostic interface. So what is TDI then? TDI is table driven interface. It is an example of a target agnostic interface. This is the target agnostic interface layer is a concept, and TDI is a type of this interface. We can potentially have more target agnostic interfaces in the future, just like TDI. But right now, TDI is the main one which we are providing. So the main objective is to enable target agnostic control applications, so that, you know, if you are writing a control plane application for a certain target, like let's say DPDK, you can easily move the same application to another target. Even like hot swap between different targets should be achievable, should not be very difficult. Who will be providing TDI support? In Intel IPUs like MEV and DPDK, then Intel switches like Tofino. Potentially in future, we can have BMV2 support as well. So anyone who wants to implement local native C++, C APIs to implement any P4 architecture, they can provide TDI support. In order to provide TDI support, it doesn't necessarily need to be tied to any P4 architecture. Anyone anyone trying to give support for let's say fixed components in their target, which does not conform to P4, they can also provide support via TDI.
Sayan, I have a question. Is there any evidence that other people besides Intel will adopt TDI and it will proliferate, or are we hoping it will do so organically through the IPDK program? Is there anything actually underway?
Well, yeah, that's the latter, I would say. We have multiple users of TDI, but outside Intel right now, because even we are in phase 1 of integrating TDI support with MEV, DPDK, and Tofino. So we are hoping that our IPDK efforts will be a guideline for other vendors to provide support.
Does Intel see TDI as kind of a sibling, let's say equivalent to like Psi for data plane? TDI is kind of a agnostic programmable data plane API with C binding, so to speak, or C++?
Yeah, good question. So I'm actually coming to that. So
okay, sorry.
No worries. So what we are going with is that the control plane applications like Psi would eventually be using TDI interface, and it won't be like a counterpart. Psi is not exactly a parallel counterpart of TDI, but rather because Psi is very networking specific. It's very switch specific, the APIs themselves. TDI is very generic. It doesn't necessarily have to do anything with networking at all. It can be the idea is potentially you could even have let's say storage or other data center components using something like TDI as their control plane front end. So this is what the idea is going to be. P4 runtime and OpenConfig would be using some kind of an adapter, just like the one which we have today in Stratum. That will in turn will be calling TDI C++. So this is the TDI repo, which is present in P4 Lang. So let me first explain these terms which are written here. A stands for architecture agnostic. AS is architecture specific, target agnostic, and target specific. So these three layers that you see, TDI, Python, the CLI, TDI C front end, which is going to be a very thin wrapper sitting on top of the TDI C++ layer. These three are going to be architecture agnostic and target agnostic. It doesn't matter what P4 architecture you want to follow, what your target is. These three interfaces don't care about it. They are going to remain the same. Over here, these boxes represent just the C++ inheritance model, but it does help in making it clear how in what kind of model we are going to follow. So TDI repo itself will contain some architecture specific but target agnostic code, like let's say PSA counter table or PNA counter table, for example. It doesn't need to, but the idea is there is an abstraction layer present inside TDI repo where you can potentially put code for these externs or these tables in. Let's say if someone wants to implement their own architecture, they can choose to not keep any architecture specific code in TDI and just keep everything for themselves. There are architecture specific and target specific table implementations, like let's say Tofino counter table, DPDK counter table, and then there are certain fixed some tables which we call as fixed tables, because they don't necessarily have anything to do with any P4 architecture, but can be very target specific, like port tables. So the idea is all of these will be following the TDI interface. That's basically the idea.
So Chris, does this answer your question of difference between Psi and TDI?
Oh, yeah,
Oh,
yeah.
okay.
Certainly. Thank you.
Quick question. So I'm just trying to see, is it similar to, if you're aware of SDK LT? There is look at everything as some logical tables and you kind of, is that the whole idea? Is it similar, or is there a way you can, if you know what is SDK LTs, can you compare or contrast?
I am not familiar with SDK LTs, I'm sorry, but the idea, what you're saying, that's exactly it. Everything is basically a table. You can design how any entity, any idea as a table, and all of our API flows, all API flows should just fit into it. Basically the way you can come up with let's say a table schema for SQL. This is very similar, just coming up with a table schema, and any hardware component can be made to conform to it.
It's I'm presuming, because you said models, this is going to be logical tables, so that because they're logical, you're able to target multiple platforms sometimes, right?
That's correct.
Okay. Then yeah.
Yes. The idea of having different architecture-based tables is the only reason behind it is that we want to allow different P4 architectures have their own evolutionary trajectory. Like if I hope most people over here are familiar with P4, and the fact that different externs look very different across architectures. So the table format can look very different, and hence the programming also would be different. That's why we want to allow that flexibility. If someone doesn't want to use that flexibility, they're also very welcome to just directly use TDI interface and not be bothered by any of the architecture specific items.
The question on that, can we go back? Because some of us have looked at other similar things, so comparing becomes a little harder. So are you saying you can use both the layers? I love the concept of this table driven. I've used it before. So, but you're also saying other than TDI, you can directly go to PSA, PNA tables, right? I mean, why is that, right? Can you add a little more color? Because I'm saying the moment you have a logical interface, if the tables are so different, they're as if they're two separate objects, right? And either you use this logical table or the other logical table because they're so different. If they're same, then you abstract them into common table, right?
So internally, let's say they'll be different, but that's why I was saying this is kind of like the C++ inheritance model. So at the top, everything is a table, but internally it might look different. So externally, no matter whether it's a PSA counter table or PNA counter table or whatever it is, you will be calling table entry add, and table entry add will always take in a key and data object, and that's it. It doesn't matter what the actual table is of. The only difference will be in how the key and data themselves look like, but the interface will remain exactly the same. That's the idea. Does that answer your question?
Yeah, it does. It does. I think I might have misunderstood because I thought you may be providing a TDI interface as well as a direct PSA, PNA, TNA counter interface, and that defeats the whole thing. It's a cool idea, and this is the right way because you have one table to. Sorry, go ahead.
Yeah, so everyone just goes through the TDI interface. So outside world just looks at the TDI interface. They need not be bothered by what the low-level tables look like. However, there are some things. For example, let's say you write a control plane application, which is and with that control plane application, you're trying to move between, let's say, DPDK and Tofino. However, DPDK and Tofino, the port tables themselves might look different internally in the sense that the tables, the way they have been designed are different. The key and data look different. So even though the API calls will be the same, the way you call it, the items that you set in your key and data, they might look different. So control plane applications will have to account for little bit of differences because eventually hardwares could be different, right?
Can I give you my view of it based on my experience with Barefoot Runtime? That might help other people a little bit.
Right. Sure.
I'm an outsider, so to speak. So I see TDI as a very thin, basic CRUD API layer to P4 type tables. And so you're going to get basic accessor operations, right? Insert, delete, read, that kind of thing. But the table schema itself is really closely tied to the, let's say, underlying objects. Like a specific table is going to have specific match keys, specific actions, that type of thing. The interface is just going to be very thin layer on top of that. And whoever's controlling the TDI has to understand the table pretty well, right? It's not super abstracted. It's just a basic accessor layer to the implementation. So if your DPDK table, port table is different than your Tofino port table, whoever's writing a TDI client has to know those details, right? It's almost like a C language binding to the P4 objects, whereas P4 runtime is a RPC binding to those objects. But it's a pretty thin layer, right? It's not super abstracted. It's not logical in the way of here's a logical routing table. Here's the table I wrote in P4 code. You have to know how to program it, right? I don't know if that's helpful or even more confusing, but it's a very thin wrapper around the implementation.
That's right. That's pretty spot on, Chris. Yeah.
Thank you.
So just to, I mean, I know that's cool. That's really good, Chris. So, but the table itself is logical. The interface may not be right. It's good to think of it as there is one logical table and each platform maps it to their own internal implementations in some sense, because it's good to strive to have a lot of tables being common and logical. There'll always be like the DPDK port table, which will look slightly different though, right?
Ken, I think that's the responsibility of like the psi layer, for example. It's the lower layer is not logical. It's pretty concrete. If you want a logical table, something above could map it between different platforms.
Okay, so this by then this is already a platform specific then. Okay.
Just to point out, this entire layer, entire TDI is supposed to be stateless. So these tables that you see, these are just representations. These are not actually, like when you do a table entry add, TDI won't be storing any state. It will just convert one form to another form. That's it. That's how we use BF runtime today as well. It doesn't store any state. What it does is it takes an input which is coming from top, which is generic, and it converts to low layer driver specific input. That's what, in very layman terms, what TDI repository strives to do. The way we achieve a generic interface is via a table schema, which Chris mentioned. I'll come back to the API overview later. Let's just quickly look at how TDI info JSON would look like. So let's say if your P4 program is looks like this. If you have a table, forward table, which contains one key field, there are a couple of actions. One of the action takes in an action param called port. This is how your TDI info JSON would look like. You'll have an array of key, an array of action specs, which internally each action will have some data inside, and then you can have some, we call these common data fields. In this table, switch ingress.forward, the forward table, you'll see that common data fields are counters, and there's one more counter field here. So this is how a structure of the schema of a table looks like. There can be multiple key fields, there can be multiple action fields, multiple data fields, and the table entry, table CRUD APIs take in a key, comma, data. Data contains this entire thing, action plus data. So it can be one action plus common data. So that's what the CRUD APIs look like. Then there are certain more properties related to a table. One is attributes, another one is operations. Attributes are per table properties. Operations are just like attributes, but they are more like triggers. Like if you want to sync counters with the hardware, you just run an operation sync counters, and your counters will be synced. This schema basically represents a table. So by looking at this, you can think that forward is a table which contains multiple entries, and each entry will contain key, comma, data. That's basically it. I hope that that makes it a little clear as to how TDI works, how TDI looks like. So every entity can be converted into key comma data. That's our entire idea. We sometimes come up with solutions with table schemas where there is no key present at all. There's just some data. We call them as keyless tables, and it basically contains just one entry. So
Sayan, question here. So I think again, a suggestion maybe, right? I think, yeah, I think I understood the not logical part of it, but P4 runtime already does a pretty good job of, on the table as an example, right? Maybe a non-table example might help in kind of seeing how that works, right? Are you saying that non-table objects are
yes.
a non-key, or there could be a table view also, right?
Yeah. So let's say, so this is a match action table, which I'm showing you. This table type is match action table. Similarly, we have tables for everything else, like for indirect counters, indirect meters, registers, hash objects. Then we have created handwritten tables. Like the compiler doesn't generate these tables. We call them as fixed tables for ports, for multicast. So for these entities, we write similar looking tables. We have concept of action for them as well, but those are more like, those can be thought of as control plane actions. So let me see if I have an example for you in my slides. Okay, so here on the right, there is a port.json snippet where the key contains def port, and data contains multiple items like speed, FEC. So this is an example table which we have written by hand. And the only thing is it conforms to the same schema, the same table schema, and you can use the same set of APIs to program port table just as you would a match action table. Does that answer your question?
Yeah, yes, it does. I think this, for somebody new to this, this is both the examples are good. The table is table to table mapping is easier to imagine. I think this explanation helps, right? For non-table objects, again, could be handwritten, could be automated also sometimes. Yeah, this is good. Yeah, thank you.
So the idea is, once as driver developers, whenever we want to map, let's say, a new fixed component or even a new P4 component to TDI, what we do is we first come up with a JSON schema. We first come up with how the table would look like, or how the tables would look like. For example, in some cases, we split up a certain component into 2 or 3 different tables where the entries might be related to each other. For example, in case of match action tables, which are let's say related to action profile tables, what we have is as match action table action action data, we have something called as an action member ID, and that points, the action member ID is actually a key in action profile table. So the data in one table is the key in another table. And internally, we put up conditions. Like first you have to put an entry in the action profile table, and then only you can go and put a corresponding entry in the matched action table. So that's the way we come up with different different tables. And yeah, so the idea is whenever coming up with support for new components, what we do is we come up with a table schema and we write the backend. We write the TDI backend. Everything else just falls into place. So entire TDI front end, every other layer that we write on top of it, let's say the C front end, CLI, then we also in BF runtime, we had gRPC layers. Everything just fell directly into place. There was no need to add any front end specific code anywhere. TDI versus P4 runtime. This is the differences are pretty obvious. I'll still go through them. So TDI primarily supports C++ and C native APIs. gRPC support via a new interface called TDI runtime will be available at some point in future. P4 runtime is primarily gRPC based. TDI is extern independent. Any new extern addition in any P4 architecture, it doesn't require front-end changes. So even though control plane applications need to know what those externs are, they need to know what the key fields, what the new key fields and data fields are going to be, but it doesn't require front-end changes. An example of this would be, let's say if you're trying to write a generic application, like let's say a CLI or an RPC server. Those are generic applications. So while those generic applications do not need to be aware of what each data field is, how many data fields there are, how many key fields there are, they are just generic applications. This kind of generic schema has helped us write many generic applications. For example, an application to cache, to create a cache out of entire TDI. It was a very small application that we had to write, which goes over every table, takes every key and data and converts it into and just throws it into a database. So TDI is external independent. P4 runtime core APIs proto do require additional changes. However, the awesome extern feature is there in P4 runtime. However, using the extern in P4 runtime, it doesn't always feel like a first-class citizen. It could be used to achieve this, to achieve similar TDI-like behavior, but there are other shortcomings. TDI APIs are based on abstract structure called table. API flow for everything is the same, whether match action, counters, or any fixed functions. API flow is different in P4 runtime. TDI is P4 architecture agnostic, can be potentially used for non-networking API. P4 runtime is, today it's tightly knit with PSA. I know that some effort has been made from compiler perspective to convert, let's say, TNA to PSA so that P4 runtime could easily work with them, but that's again that requires compiler effort. That's all I had. Any questions at this point?
Thanks, Sayan, for the presentation. I do have a question to get us started. So maybe two questions. What would you say was the most challenging functionality to represent using a table schema? But because we talked about match action tables, of course, and we talked about the port table, but there are other things as well. And I guess a related question would be, how do you handle information flow in the other direction? For example, things like possibly packet ins and aging notifications and things like this.
Right. So notifications are handled via attributes right now. Attributes in BFRT were very specific, and adding any attribute led us to add code in each and every layer. However, we have converted attributes into a very generic structure in TDI. To answer your first question, Antonin, I would say the most challenging, even right now, we are facing is to convert some of our existing attributes into tables. Like one of the items which is in our future roadmap is that we want to convert idle table, idle notifications, which exists as an attribute. We want to convert that functionality into a table as well. In future, we want to convert learn, which you might very well know. We had a lot of challenge representing learn as a table, but that is in our future roadmap, that we want to get rid of learn as parallel to tables. Right now, that's how it exists. We want to get rid of that and convert it into a table as well. As per your second question, that's we achieve notification callback registration via attributes. Packet in and packet out will also have like the downward direction. The downward direction will be via tables. The upward direction will be via notification callbacks. That's how it would be. I'm not sure if that answers your question.
No, it does. Thanks for the details. Yeah.
All right. So folks who are no other questions, folks who are already familiar with BFRT, I wanted to touch up a little upon.
Before we go there, Sayan, I think Vladimir raised his hand. I think maybe you wanted to either react to my question or ask another question.
Yes, I actually wanted to kind of tell you about a couple of things that can be done to actually make things that you asked very, very nicely within the same infrastructure. So imagine a very simple thing that you can add to P4 runtime, or that can be added to the TDI, and that is the ability for an entity to register for any table changes. This is something that other people do in other places, and it is very helpful for things which might be totally unrelated. Like, for example, you might want to register to receive a notification every time someone adds an entry or removes an entry because you want to debug. So this is becomes a very generic mechanism, like a standard method that can be added to any table, and that allows you to handle things like, for example, once something changes on the table, even from the hardware standpoint, you can receive a notification, and so that way you can handle things like idle timeout and so on. But also, if you want to, it allows you to use the same structure for things like packet transmit and packet receive. So for example, imagine a table. You don't have to do it, but you can imagine a table where individual entry is a packet. And so every time you receive a packet, you receive a notification that a new entry has been added to that table, right? Or, for example, if you want to transmit, you add an entry to the table, which essentially is your kind of queue, and that causes the packet to be transmitted. Again, you can have packet IO totally outside and continue doing the same things as can be done before on time, but there are multiple ways how those things can be represented through the same very generic mechanism. And remember that even for the tables which never change, you can still have those methods because they are generic, and then it's just a matter of whether they will be ever called, the callback will be called or not. So those are things that how you can have a uniform structure while still very, very simple and very, very generic.
Thanks for the explanation, Vlad. Just a quick follow-up. When you use a table for packets, what's the key?
So this is a great question. So one thing you can do is you can have, for example, a serial number, right? So every time you receive a packet, you just increase the number. You can have a timestamp. You can decide whatever you want. Or the other thing that one thing that really has not been really thought through yet is kind of the generic types of tables. So far, you know, I think one of the main challenges in today's implementations, we have too many of those. But there could be tables potentially where you have entries. Sayan kind of mentioned about that without any keys. But you know, one thing is that you might decide that you can have entries where you have handles on the entries, and then you know, you don't really care about the keys that much. So those would be probably the answers today. And then this is something that probably makes sense to figure out early enough. And if we decide to, for example, do packets as tables.
Thanks.
Right. Some other ways in which the entry level notification, the table entry add or delete notification could be achieved. Like this is a problem we were discussing a while ago. One of the ways in this could be achieved is you can always have another table in which each entry corresponds to each of the other tables, and the data is basically a notification notification function address. That's one way to implement it. So yeah, just throwing it out that one of the ways in which we solve some of our problems.
So maybe one other quick comment on this. This idea of being able to register for callbacks, I think, is like a super powerful mechanism that's common in more generic table-based APIs. So definitely, you know, agree that that's going to be useful here. The other thing that we've seen in a lot of APIs is something like a pub sub, where you can have like more ephemeral notifications or events that aren't necessarily going into a table structure. I mean, is there a place for something like topics and a publish subscribe mechanism, or do we think that that can just be entirely implemented through this table write and table callback method?
So currently the idea is that any kind of that something like that should be achieved via table mechanism.
Okay.
But if the community feels that that is something which inherently becomes a property, a table property, which should be like a part of the table schema itself, I think we should go ahead and add it. That is completely up to the community how we want to proceed. So
to add to Brian's point, one use case that I see is like for telemetry type of data where we want something to flow continuously. Will a more easier interface work Of course, tables can work, but in terms of size and other things will be at limitations.
I think if we sort of think about the problem overall, there are several orthogonal things that we need to be thinking about, right? So one is, and to me, that's one of the most important ones, is really to describe in a greater detail that we even presenting today, what the base object, the table is, because the more generic and the more powerful that base object is, the easier it becomes for everyone. Because in that case, you have the base knowledge, I can operate with tables, and then all the other objects which are derived from that base object, you just need to learn an extension here, an extension there, and that's normal. Whereas, and that is pretty much the main difference between TDI and before runtime. And before runtime, if you think about that, they're objects as well, but the base object, the commonality between them is kind of doesn't exist. It's an empty object. So, you use one way to work with tables and one way to work with counters. And so I think the main learning that we have is that the more powerful the base object is, and that's what I would like to concentrate on, the easier it is and the less work you need to do to deal with everything else. And then separately from that is the specific protocol implementation, like which messages the client and the server should exchange, and how the, for example, one can register callbacks and subscribe for whatever notifications that they would like. And obviously, one other thing that we need to think about is that there's a local API, locally callable API, and that is another thing that we want to make sure is defined very, very clearly, right? So people can just call functions in C or C++, and there is a messaging API, which is gRPC based. So those are sort of orthogonal things that, can be discussed separately, but at the end of the day, need to come together.
Vladimir, it sounds like you're describing P4 runtime 2.0.
You can
or TDI 2.0, right?
Well, sorry.
We can't say anything confidential.
Are there any objections?
No. I have a question though. I think, Vlad, so that is the right, I'm just based on some experience elsewhere, right? I think we said to start with TDI is lightweight. So you want to keep it lightweight. And then having that concept of a base object is powerful, right? There are many things that will come up. There could be one layer above, right? One could be caching, right? Another could be this, there will, like even FIFO can be an attribute, right? When you want to learn MAC address learning, let us say, you have base tables, but some of these other concepts become the next layer. So that PubSub or caching or adding additional attributes. Keeping that base layer helps. Again, I'm just saying it based on experience with another table interface. But keeping the base simple helps us, be nimble. Absolutely.
I actually wanted to say one other thing that I was discussing with one of my colleagues, and that's kind of a reaction to Chris's comment. There is one actually easy way to reconcile TDI and P4 runtime if you want to, right? So imagine you have a program. It has match action tables and it has counters, right? And so in today's P4 runtime, you will have a table object and you will have a counter object. And in TDI, you'll have one table and the second table. Well, nothing prevents you from exposing the second table through P4 runtime as a table as well, right? It just actually becomes a very simple wrapper. And it just so happens that other objects you will start using less, and you'll start using the P4 runtime table interface more. That's another kind of way to think about this.
So Sayan, you mentioned there was going to be possibly a remote version of TDI over gRPC.
Yes. So right now, you're familiar with the be a front-time gRPC, right? So we will be having a similar RPC mechanism for TDI in future. However, how much further up ahead in future, that's something that hasn't been discussed yet. It's not there in our immediate roadmap, but it will be there.
Is that the opportunity for this P4 runtime 2.0 I was whimsically referring to?
I guess, yeah. So
We'll leave the naming to the other people.
Right.
But today the proposal was TDI, although it wasn't planned.
I mean, there's so much going on in the industry right now where there's been a lot of learnings. We've seen actual commercial progress in some areas and not in others. It seemed like there'd be some opportunity to do some retrospective and figure out, what's the future roadmap from a community perspective, and how does that overlap with commercial roadmaps that people are laying down?
I can't speak for anyone else, but I can say that, TDI and P4 runtime can coexist for a long time, perhaps indefinitely, and there'll be times when one's appropriate and the other is appropriate, perhaps, going on. So, but yeah, I mean, if folks want to merge them together or come up with a future roadmap, that's fine too.
I mean, there's been talks of P4 runtime v2 for a long time now, and there's certainly things that we can learn from other projects like TDI, but it does take a lot of goodwill from a lot of people and companies to make that change, right? So it's one thing to push for your API and have it implemented on your products, but when you get to the community, right? I mean, P4 runtime is implemented on BMV2. From a community perspective, a lot of people appreciate having a virtual switch that they can program in P4 and with P4 runtime. So I think evolving the API is great, and there's definitely things that we should change, but it takes a lot of goodwill to kind of update all those implementations and update the entire ecosystem as a whole.
If I could translate the word goodwill into blood, sweat, and tears and coding.
Well, and we've also, we see the PINS project, right? They're integrating P4 runtime into Sonic, so to speak. And there's probably been integration learnings as well. And out of all of this, I imagine some wise architects could come up with some insights to say, if we move things in this certain direction, all this would be easier the next time. Here's what we learned, here's what we would do differently. And those become inputs into a new standard someday. But you're right, that's a lot of goodwill. I mean, P4 runtime, right? Man-years of work just in defining it, let alone implementing it. But that's what these kind of working groups do, right? Come up with these kinds of things.
Hey, so Chris, it may not be a bad idea to, present that summary, what is going on in the industry. We all can learn from that.
Yeah, I'm kind of the fly on the wall. I'm not sure I'm that person. But I know there's people in this meeting right here who have a lot more insight into this, but I'm not volunteering anybody.
Okay.
And there's a Dash project too, which is interesting, and people might want to learn about that Microsoft is spearheading. That's think of it as DPUs or SmartNICs treated as bumps in the wire for data centers.
I think ultimately, the way I look at the work of some of these groups is not so much to say prescribe what people are supposed to use and code for, but to sort of describe the useful things that have been done, and just make sure that those things are described in such a way that other people can join and do their own implementations and things like that. So in that sense, I agree with Andy that there's nothing that prevents P4 runtime and TDI for coexisting for a long, long time. What we do know, at least today, is that you know, it has not been sufficient to operate our devices. And the customers who even chose and went to the pain of programming parts of Tofino, for example, using P4 runtime, had to resort to other APIs to complete the work. And that is sort of, I mean, imagine, I mean, there are some languages that use multiple alphabets, but usually it's kind of difficult. And it's unnecessary pain for people.
Coming back to, I don't have anything else. So that was all from my side.
Well, thanks, Sayan. We're just about out of time here, so great timing. I want to thank you for presenting, and thank everyone for chiming in. I think we had a great discussion here. This was recorded, so I will share the link to the recording with everyone. Thanks, and lots of food for thought, I think.
Thanks, Sayan.
Have a good weekend, guys.
All right.
Thanks,
you.
see ya.
Thank you.
Thanks,
Great
everyone.
presentation.